Dobrodošli. Ovo je Phoenix kanal.
Jao, nema zakrivljenja. Nema zakrivljenja. Nema zakrivljenja.
You man! You stupid man!
Go fast, rocket. I onda rocket amateur. Evo. Ravno.
You man! You stupid man!
Ravno. Antikrepuskularni zrake, evo, to je sve što mogu da za sada kažem, ali to je jedna od stvari koju recimo ljudi, globoljupci ili prijatelji sa druge koji razmišljaju drugčije, koji vjeruju još uvijek, koji ne mogu da shvate. Isti taj pojav prisutan je svugdje, znači kod svake kamere, kod svake orisa, nacrta, šta god. Znači mi gledamo sada prema istoku, tu bi sunce treba da bi izlazilo, ali u stvari to je vreme kad sunce odlazi. Ali još uvijek kad okrenemo hrbet, znači iza nas sunce odlazi, a pred nama sunce dolazi.
Znači sunce je istovremeno i na zapadu i na istoku. Zanimljivo.
You man! You stupid man!
Isto takvu sliku imamo sa onog kraja, samo da tu se vidi sunce kako odlazi, najčešće, i zrake se šire prema nama. No sad tu smo okrenuti hrbtom i to je ono što vi ne shvaćate, jer po vašome mi bi trebali da vidimo još uvijek zrake ovako kako idu, da bi vaš model zvijezda radio.
Zaboravio si na perspektivu koju si malo pre pominjao. Pošto po heliocentričnom modelu sunčevi zraci dolaze paralelno, logično je da će se u perspektivi upravo ovako i videti kao na ovoj slici. Kako možeš ovako lupetati da će paralelne zrake sunca na modelu globusa da se razilaze? To ne predviđa zakon perspektive.
You man! You stupid, stupid man!
I perspektiva je uvijek radi. Bez obzira da li vjerujete vi u nju ili ne.
Zakon perspektive je isti i prema istoku i prema zapadu.
You man! You stupid, stupid man!
Gledaj Petre sada kao želiš. Gledaj sad Petre kad gledaš luči na nebu. Evo sad ovako bi trebalo da bude na globusu. Vidiš kako je nacrtano, vidiš? Kako idu zvijezde prema gore, pošto ti ideš prema dole, jel tako? Evo, tako bi trebalo da bude. I sada, nećeš vjerovati, ali ima pilota koji stave tamo kamericu lijepo, cik, na konzolu i ona snima. Evo još jedan put pogledamo kako bi to trebalo da izgleda.
You man! You stupid, stupid man!
Ovdje je postavljena kamera da se kreće duž površine zemlje da bi oponašala let aviona, ali se zvezde ne rotiraju kao u realnom snimku.
Da ne zaboravimo. Ops! Idemo u realnost sada. Opa, nešto se ne dižu te zvezde, a Petre?
Ali Google Earth ne oponaša rotaciju zemlje, to jest ne oponaša rotaciju neba oko južnog pola tokom ovog vremenskog intervala koji traje nekoliko sati.
Kako te tvoje luči? Jeboj. A vidiš? Le. Baš te ne vole, a? One ne ide ni gore, nigdje. Tamo su, vidiš, tamo, to je lepo. A? I gledaj luči, gledaj Petre. Petre, gledaj luči, Petre, ne kreću se prema gore kao na modelu.
Google Earth, kao što rekoh, ne podržava rotaciju zvezda dok se krećeš preko površine. Pošto zvezde u realnosti rotiraju oko južnog pola, snimak noćnog neba iz aviona u potpunosti potvrđuje da je Zemlja globus. Uostalom, pogledajmo pravu simulaciju leta aviona pomoću softvera za predviđanje na globusu. Uradio ga je kanal Astronomy Live, pa pogledajmo.
Hi folks, Astronomy Live here. MC Toon recently contacted me, asking me to do some analysis on a time-lapse that was focused on by Taboo Conspiracy. This time-lapse you see here, shot from a plane flying from Zurich, Switzerland to Sao Paulo, Brazil. It's quite beautiful. You can see the Milky Way and all these stars, but Taboo Conspiracy claims that this pilot has debunked the globe accidentally. Let's take a quick look at Taboo Conspiracy's commentary on this video and find out why he thinks this video debunks the globe.
If I had a stunning view of the stars at the beginning of my flight, as time progresses and the nose of the plane drops to account for the curvature of the Earth, the stars should appear to rise up like this. In fact, the nose of the airplane is allegedly dropping, while the stars, which are somewhat fixed and allegedly separate from the Earth, should appear to rise up if we lived on a ball. But you don't need to believe my illustrations. Fortunately, Google Earth allows us to model this same flight with the stars in the background and shows us exactly what would happen if we lived on a globe. For this Google Earth model, I used our distance of roughly 3,000 miles on the exact same flight route that I showed earlier. I set the altitude at 10,000 meters or 32,800 feet. Remember, this is how the globe should work. Now, watch the stars. There's no question about it. As the viewpoint continually dips, the stars rise up, exactly as we would logically expect if we lived on a ball.
So what's wrong with this picture? Why doesn't the actual flight look like this video from Google Earth? The answer is simple. Although Taboo Conspiracy has set the Google Earth camera to fly along the surface to try to mimic the flight, it's not mimicking the rotation of the Earth or the changing time of night during the course of this time-lapse, which is over several hours. If we want to see what the globe actually predicts for this time-lapse, the first step is to astrometrically solve the pictures. That means to determine the coordinates of these pictures based on the positions of the stars in the frame. We can then compare this to what the globe actually predicts. Once we've got a solution for each frame, we can overlay constellation figures back on top of the original time-lapse and see how good of a match we've got. Although there's some wobble, especially at the edges of the field of view, we'll use the coordinates for the center of the field of view and compare to what the globe predicts for this flight. Next, we need to know the latitude and longitude of the flight over the course of the time-lapse, and you can pull this kind of data from a site like FlightAware. I used the coordinates of the flight from August 8, 2023 as a proxy for the actual flight that occurred way back around August 8, 2016, give or take a day. Although this isn't a perfect match for the actual flight that occurred way back in 2016, it's good enough for our purposes. Next, we need a program that will actually simulate where the stars and constellations should be from a given location on Earth at a given time, and for this I have my own custom planetarium software that I developed a few years ago, and I've now adapted for this purpose. I can feed into it now the data from FlightAware as well as the astrometric data from the actual time-lapse and compare the two and see what the flight should have seen from its location over time. As you might expect, I've made the full source code available as a link in the video description, along with all of the raw data, including all of the flight data from FlightAware and the astrometric data from the actual time-lapse, so that you can rerun this yourself and confirm my findings. The only change I made to the FlightAware data is I changed the year from 2023 to 2016 to reflect the actual date of the flight, so that we can see what the stars should look like from that date and time. Now when we take a look at the results from running my planetarium program, we get an all-sky view. To orient you, north is at the very top of the frame, south is at the very bottom, east is to the left, and west is to the right. Now, if you're not familiar with all-sky planetarium charts, you might be wondering, why is west to the right and east to the left? Well, if you're laying down on Earth looking up at the sky, with your head pointed to the north and your feet pointed to the south, what is to your right? West. What is to your left? East. This planetarium all-sky chart is designed to reflect the sky above you, not the ground below you. Coming back to our planetarium program results, we have the time and date progressing in the top left, and the latitude and the longitude of the flight changing over time. Each frame from the original time-lapse took about 5 seconds. It was a 2.5 second exposure, and it seems like they probably had long exposure compensation on, meaning the camera closed its shutter and took another 2.5 second picture to subtract out noise and hot pixels. So the total time between pictures is about 5 seconds, and this seems to match well with how long it takes to get from one landmark to the next in the time-lapse. So, in the bottom right, we have a couple of circles. The red circle represents the astrometric solution, that is to say, the center of the frame in the actual time-lapse over time. The green circle represents the course that the plane took on August 8, 2023 for comparison, flying a similar route. While this all-sky planetarium view is pretty intuitive to amateur astronomers like myself who are accustomed to reading such charts, it may not be entirely intuitive to the average layperson looking at this. So let's reproject this view to make it a little more intuitive, and do a side-by-side comparison of what the globe predicts versus what was actually seen from the flight. And here we have the side-by-side. On the left, I've reprojected the video from my planetarium software to simulate the view from the flight, and on the right we have the original video annotated with the constellation figures. Now, the way that the astrometry.net software drew constellation figures over the frames on the right differs a little bit in terms of how my planetarium software draws constellation figures and which stars it connects the dots on, but the stars are the same, and we can see the overall motion of the constellations is the same in the globe prediction and in the original annotated video. So no, this flight does not debunk the globe. In fact, it agrees with the globe perfectly. I'm going to let the rest of this side-by-side comparison play out till the end, but until next time, thanks for watching, and clear skies.
Gledaj zvijezde ovako, vidiš Luči kako bi trebalo da ide, evo, točno na tom delu.
Crni Radovane, sam si sebi najveći krivac, Radovane, sad si jadan, čemeran i upadljivo glup.
Produkcija Phoenix kanal.